What day is today? Tuesday? Tuesday greetings, everyone. Can everybody hear me and see me? Or can anybody hear me and see me? Good start.
There's an neat little sit at the foot of the hill. Smoke curls up to the sky. By a whiff of the smell you can plainly tell there's Pudgy and Prue nearby. For it fills the air with a perfume rare betwixt both me and you. We'll take a sup or drink a cup or a bucket of Mountain Dew.
Yes, there is a candle on my desk. There's also a cat on the chair. His name is King Kenny. I recommend both candles and cats. Okay, I think everybody can see my screen. Is that true? There seems to be some delay going on with Teams. Can anybody hear me or see my screen? Okay, good. Okay, so we are going to talk about collaborations and class relationships today. Before I jump in, okay, now this seems that Teams is recovered. Yeah. I've put the lecture recordings from last week on Moodle, so they're all there. You can find all the lecture recordings, for example, on version control and JavaDoc. You can find the NetBeans and version control demos, and you can find the lectures on objects and responsibilities on there as well, the recorded lectures. There is also a copy of them on Microsoft Teams Stream as well, so you can find links to them there. The ones on Moodle have been edited, so after I record them, I do a little bit of editing and then I upload them, so it takes some time. Okay, let's talk about collaborations and class relationships. So a collaboration is another word for communication. We're just talking about communication between objects and classes. That's all we're talking about. And this is the difficult part about object-oriented design, actually. It's trying to understand the pattern of communication between objects and classes. This is like the thing, I would say, that makes object-oriented design tricky. Right, if you had just one program, one main method, and it just, you start from start to finish, it wouldn't be very difficult to see how the program works and how it flows and how it processes information from start to finish. But when you have an object-oriented design, it is difficult to understand how communication works and how the program works. That's one of the challenges. So collaborations represent a request from a client to a server. The client has a responsibility to perform. So it may be able to fulfill that responsibility by itself, or it may need help from other classes. And we're going to often be using this client-server terminology. I think everybody's very familiar with client-server terminology in general, right? A server provides services representing its responsibilities. These are some new terms that we introduced last week. And a single collaboration is one way from client to server. But that does not mean that information only flows in one direction. So a client makes a request, like asks a question to a server, and then the server supplies an answer in the form of a return statement. Or maybe the client passes an object reference and the server populates the object reference with information and returns the object. Each collaboration addresses one responsibility in the server, and each collaboration helps to fulfill one responsibility in the client. So this is what the idea looks like if we try to draw it as a diagram. We have a collaboration represented by an edge, and the edge is given this label A1. So this is a communication. And then the rectangles are objects or classes. So class A, and it has a responsibility labeled A1. And then in order for class A to fulfill its responsibility A1, it needs to collaborate with two other classes, class B and class C. So class A and class B have a communication or a collaboration, and it's represented by this directed edge. There's actually an arrow there, a small arrowhead, that's a directed edge. And that collaboration is given a label, and it's called B1. And class B is responsible for collaboration B1, and class C is responsible for collaboration C1. So that's what it looks like in a drawing or a visual form, this idea, the communication between classes. And I think you've all seen diagrams like this before already in UML style. So we're going to look at patterns of class collaborations and relationships, right? Trying to understand the flow of control and the flow of data in a software system, right? This is a huge challenge, right? Especially when you have hundreds or thousands of classes. And this defines the pattern of communication. And we can use this also to help identify subsystems, which leads to another level of encapsulation. And as a forward reference, we're going to see this concept we're going to have a lecture on subsystems, but subsystems are used also in design patterns. So you've probably all heard about design patterns before, but design patterns are often made up of subsystems, and we're going to go into that in some detail. Okay, so how do we find and identify class collaborations and relationships? Now, if we can remember, the first stage of the object-oriented design was to identify objects. The second stage was to identify responsibilities. The third stage was to assign the responsibilities to classes. And now we're looking at finding classes that collaborate in the relationships between the classes. So we're looking for dependencies among responsibilities. So for each responsibility of each class, a for loop, we answer the following questions. Is a class capable of fulfilling its responsibility by itself? If not, what does it need? What other classes does it need, for example? From which other classes can it acquire what it needs? And shared responsibilities also define and identify collaborations. And we have to look at each class and ask ourselves, what does this class do or know? And what other classes does this class need? What are the actions or information it needs from other classes? If there are no interactions with any other classes, there's a chance that you can eliminate that class altogether, right? And these you can identify this using walkthroughs, right? Walkthroughs that identify how your system behaves. In the coursework, for example, you can identify this through method calls, right? A method call generally means that you're having a class that collaborates. So here are some kinds of class relationships. We have mentioned some of these already. So finding collaborations is facilitated by examining different kinds of relationships. The is part of relationship. We already mentioned this and talked about this. This isn't going away. It's going to keep coming up. By the way, that's how you identify important topics. The most important topics are the ones that keep coming up over and over again. So the is part of relationship defines a whole part relationship between two classes, right? One class is a composite object. The other is a component, right? So a body consists of legs and arms. An arm consists of like hands, forearm, elbow, shoulder, right? Those is part of relationships. And composite objects usually have the responsibility for maintaining information about its components. So in an is part of relationship, let's say the object that's at the top of the object hierarchy knows about its component objects. So the body knows about the body parts, right? The body controls the body parts, right? The body object controls the arms and the hands and the legs. And that is the composite object relationship. That's not always true, by the way. And I'm making a forward reference here to the factory design pattern, right? So this actually ties into a design pattern that's coming in the future. There is also a has knowledge of type of relationship. If a class A knows that a class B exists, this usually implies some sort of a collaboration, right? Typically, A collaborates with B for a service, though the server may need to have information from the client as well, right? Like, for example, drawing elements is associated with control points, right? That's our drawing editor example. Right, if you draw a rectangle, for example, a rectangle is usually defined by control points. And those are the points at the corners of the rectangle that you can click on and move them around to change the size of the rectangle, right? Another kind of relationship is depends on, which is similar to the has knowledge of relationship. But there may be a third class that makes and maintains the dependency. And I'm making another forward reference here to the observer design pattern. So this depends upon relationship. It comes up over and over again. Has knowledge kind of relationship comes up over and over again, and so does the has part of or is part of relationship. These come up repeatedly over and over again. So we make a distinction between composite and container objects. I was just talking a lot about composite objects, and these are formed of so-called object hierarchies. Remember, we're making a distinction between object hierarchies and class hierarchies. I know that the terminology does sound confusing. It does. But once it clicks, it's actually not confusing. A class hierarchy describes the is kind of relationship, right? Like a house cat is a kind of cat. That's the class hierarchy. The object hierarchy defines a composite relationship, and that is like the leg is part of a body, right? That's a composite hierarchy. So we're talking on this slide about composite objects. Each component has a different role to play in a composite object, right? So in the body example, you have the arms, the legs, the heart, the lungs, and all that stuff. And the composite object is responsible for its parts. It knows about its parts. But the parts do not have to know about the composite. They provide a service to it. So the hand doesn't have to know about the body. The body has to know about the hand, but theoretically you could cut off a hand and replace it with a new one. That is theoretically possible because the hand doesn't have to know about the body. It's not the world's best example. Maybe the tire is a better example. You can replace a tire. The tire doesn't have to know about the car, but the car should know about the tire. And a composite object collaborates with its components. So the car tells the tire when to rotate. And this is opposed to another kind of object, another kind of relationship, container objects, which are like sets, arrays, and lists. Every element in a container object is functionally identical as far as the container is concerned. So every element is treated exactly the same way in a container object. So every element in the container object serves the same purpose or plays the same role. And containers may need to collaborate with their elements, but usually a container responsibility is just passed along to all the elements, like sum, display, search, and so on. So you can think of arrays like arrays of integers. Every integer is treated exactly the same. It doesn't matter what that array is or what that set is. Every component of the array is treated exactly the same way. Please interrupt or stop me if you have questions. So this is a way to actually record collaborations, right? If you were given a requirement specification, that stage one would be going through the requirement specification and identifying objects. Stage two would be going through again and identifying responsibilities. Stage three would be assigning the responsibilities to classes. And then you would start constructing these class cards. This is a dynamic process, and the original authors of this book recommend index cards, where you're actually getting out index cards very, very similar to Post-it notes. And you're writing down the names of the classes and writing down their responsibilities. And then the next stage is writing down the collaborations on these index cards. They're called class cards in this book, right? So for each client responsibility, write the collaborating server classes. And you can see that here in the second column. So here we have the class name called Creation Tool, which is a reference back to our drawing editor example. There's a superclass called Tool. So Creation Tool is a kind of tool. Subclasses are Line Creation Tool and Rectangle Creation Tool. Say that 10 times fast. A Line Creation Tool is a type of tool. A Rectangle Creation Tool is a kind of tool. The responsibilities are accepting appropriate input, determining location, and creating a new instance. And in order to fulfill these responsibilities, the creation tool class collaborates with the user input class once, twice, and then also the drawing element class. Does that make any sense? I hope it does make sense to everybody. By the way, here's a question for the audience. In the developing maintainable software module in the coursework, you're given a piece of software, right? You're not creating one from scratch. Does anybody know how you might be able to identify the collaborations in an existing piece of software? I'll wait and see if there are any brave, courageous feeling students. The coursework is going to be given out very soon, probably this week. Yes, so one of the answers, yep, that's true. So one of the answers is you can find collaborations in existing software by reading the source code and trying to manually construct the collaborations, right? When you see one object calling another object's method, that's a collaboration. And you can look at that by reading the source code manually. Yep, that's correct too. Looking at the documentation should help identify collaborations. In the ideal world, that would be true. In reality, you find that not very often, I would say. Can anybody think of any other ways? So there's a way that's automatic. And this is the big question. Are there any automatic ways to find collaborations? If those automatic ways existed, that would be a cool thing to know, wouldn't it? Yes, this could be done manually by looking at the source code and then drawing each object and then drawing the collaboration with an edge to another object and then labeling that object. That is certainly possible, right? Can anybody think of an automatic way to identify collaborations? Does anybody know of an automatic way to do this? So if you don't know about an automatic way, then this lecture is very educational. So nobody knows an automatic way to do this. Imagine you have a piece of software. I don't know what code scene is, actually. I don't know what code scene is. That could be a correct answer if I knew what that was. But imagine you're given a piece of software that's hundreds of thousands of lines of code, or millions of lines of code, or hundreds of classes, like a very complicated piece of software, which is true about most pieces of software. One automatic way to extract the collaborations is with a magic tool called Doxygen. So we mentioned Doxygen last week, but Doxygen is a source code documentation tool, and part of this tool actually draws diagrams. So Doxygen it automatically extracts class hierarchy diagrams and collaboration graphs. These are two of them. It is truly an amazing piece of software. It is really, really amazing. And at my last job, there were last software engineering job, there were lots of red flags that I was working on a failing project. First red flag was no coding conventions. So as soon as I saw the source code, I could see, but no, JavaDoc does not produce diagrams that I'm aware of. If somebody else finds out that JavaDoc does produce the diagrams, please let us know. But last time I checked, JavaDoc still does not produce these diagrams. At my last job, there were 3 red flags that I was working on a failing project. The first red flag, which I noticed immediately, was no coding conventions. Right? This is a major red flag. Second major red flag was the object-oriented design. The developers were not following the object-oriented design naming conventions. So two naming conventions are objects and classes are nouns and methods are verbs. They were sometimes following this convention and sometimes not following this convention. But if you discover that the developers are not following this convention, that's a red flag for a failing project. The third red flag for that failing project was the documentation. There was no systematic documentation applied to the source code. So when I got there, I actually introduced the company to this tool, Doxygen, for documentation. That's a major red flag, by the way. If you're doing that, you're in trouble. But anyways, I introduced the company to this Doxygen tool, and they had already been working on some software for a few years. And so when we applied the Doxygen to the software, it generated these unbelievable collaboration graphs and class hierarchies, and it exposed some problems with the software. But those diagrams give a lot of insight into what the software looks like, its patterns of communication, and the collaborations that it uses. So really, really great, amazing software, actually. Okay, that's all we're going to say about collaborations, actually. And here is some related reading on that topic. Are there any questions about collaborations? If there are questions, feel free to ask at any time. I'm going to suggest that we jump into the next topic, actually. I would suggest we use this time to start the next lecture, and then, with some luck, we will finish earlier on Friday. What is the... I'm not sure I understand this question. What is depend upon looks like? So they all look, in graphic terms, they look very similar. In the notation of the book, depends upon is a rectangle, and then there's an edge, a directed edge from that rectangle, and it points to another rectangle, right? So it looks very similar. Yes. This is very abstract. Yes, it is abstract at this point. And it helps to see, maybe I can quickly show some things. So Doxygen collaboration graph. Let's see if this works. I did not prepare this ahead of time. So look, these are the amazing graphs that Doxygen can produce automatically if you give it source code, it will automatically extract the collaborations. And here's one of them, right? Here's a collaboration graph from a piece of software. So you have to comment the software the same as you would with JavaDoc, using the same tags, the same conventions, and then you run it through the Doxygen program, and it will output the source code documentation and the collaboration graphs and the hierarchy diagrams. So it's a very, very impressive piece of software. It's amazing, actually. I think it's absolutely amazing. But the Doxygen uses another piece of software for drawing graphs, right? So it has another piece of software for drawing graphs. And this is, for example, one of the class hierarchies, right? So that's what it looks like. So hopefully it's not as abstract anymore. Once you can see something in action, hopefully it's not as abstract, right? This is another collaboration diagram. Feel free to have a look at this. So the class diagram looks more like, the class diagram looks more like this, and actually UML kind of can combine different kinds of diagrams. So a standard, in my opinion, a standard class diagram shows the is kind of relationships. So for example, a class hierarchy, that's, in my mind, that's a good class diagram, but UML can combine the is kind of, the hierarchy diagrams with collaboration diagrams. And the way you can see the difference in the relationships, the different relationships are encoded in the edges and the arrows. So there are solid edges, there are dashed edges, there are outline arrows where you just see the outline, and then there are filled arrows, and there are diamonds that show like the one-to-one or one-to-many relationships, and then there are solid diamonds and outline diamonds. I'm not going to go deep into UML right now, but that's the idea. And for UML is very complicated, so really you need a reference manual or some sort of a reference document, because UML diagrams are very complicated, right? I cannot remember everything in that UML, all of the UML notation. When I look at a UML diagram, I need to get out my reference to make sure I know what the dashed edges mean and what the solid edges mean, and the difference between the filled triangles and the solid triangles, and the filled diamonds and the solid diamonds, and so on. So I can't remember all that stuff, right? Any other questions? Okay, let's look at the next topic then. Hierarchies. Hierarchies. You've seen hierarchies already. We're just going to look at hierarchies in a little bit more detail, and we're also going to point out some things that can go wrong in hierarchies. Like I mentioned, I have seen hierarchies go wrong before. I've seen them go wrong in the classroom, and I've seen them go wrong in industry as well. They're not complicated, they're not, but somehow people get them confused. I guess I understand why people get them confused, but I don't fully understand why people get them confused. I think it's basically one of the things that happens when you go into the real world, so to speak. One of the things that happens is you maybe you start working as a developer. You'll discover that a lot of the members in your development team or in your department have no background in computer science. This happens a lot. So at the last job I was at as a software developer, there was only one other developer that had an actual degree in computer science. And I think this is basically one of the reasons why software hierarchies go so wrong and software design goes so wrong, because the people that are writing the software just haven't been through this educational process. And a lot of the developers there were dropouts, actually, from, they started university and they dropped out. Or maybe they had a degree in mathematics, for example. I remember one of my managers had a degree in economics, which is very far away from software and computer science. And one of my colleagues had a degree in engineering, for example, which is helpful, but it's still not computer science. So this stuff goes very wrong a lot in the real world. It's just because a lot of people don't go through this process of a computer science degree. It is difficult. Like, getting a computer science degree is difficult, and some people don't go through that process because it is a difficult process. Okay, so let's look at these class relationships in some depth in these class hierarchies. So we've gone through the process of identifying objects, identifying responsibilities, assigning those responsibilities to classes, and then identifying collaborations. And that is our preliminary design phase for software. Now, designing class hierarchies is the next step, right? And the class hierarchies are one of the best features of object-oriented design because they support essentially code reuse. You're identifying behavior that's shared amongst several classes, and you're abstracting that shared behavior upwards so that it can be reused. The same code and the same methods can be reused over and over again, right? This is one of the benefits of object-oriented design. This is one of the goals, right? Without any class hierarchies, we're losing massive benefits offered by object-oriented design, right? A great question, if you're sitting in your C programming class, a great question to ask the lecturer is, how do you implement polymorphism in C? Or how do you implement inheritance in C? And these kinds of questions. How do you implement encapsulation in C? These are all great questions you can challenge the lecturer of a C module with. I guess you guys wish you knew that last year to ask those questions. But these are great questions to ask when you're taking your C module. So class hierarchies represent the essence of the object-oriented design and provide a lot of potential benefits, right? They also offer a global view of a design as we can understand it and improve it. And to help us understand and depict class hierarchies, we have a few different tools at our disposal: hierarchy graphs, Venn diagrams and contracts. Does anybody remember? Yes, these slides have been up. Oh, no, the hierarchy slides have not yet been uploaded to Moodle. I will do that as soon as we're finished. We're going to be finished in just like 10 minutes anyway, so it's just a 10-minute start on hierarchies. Anybody remember what a Venn diagram is? Anybody seen a Venn diagram before? I think I actually cannot remember when Venn diagrams were used in my education precisely, and the first time I saw them. I actually cannot remember. I don't remember when I first saw Venn diagrams. I'm not sure if I saw them in high school or not. I don't remember ever seeing them in high school. I think the university was the first time I saw them. Primary school, that's early. Anyway, we're going to see some Venn diagrams here. I really can't remember the first time I learned Venn diagrams. I don't think they were ever explicitly taught. I think they were just used at some point. But it would be a good thing to teach in like a mathematics class, actually. It really makes sense to introduce that as a topic for mathematics pretty early on. Yeah, primary school would be a good place to start using Venn diagrams. Okay, so here is a hierarchy graph. That's good. I'm learning some things about the UK educational system. I'm not from the UK, by the way. So you guys can teach me some things about the UK educational system. I don't know that much about the anything below the university level. So hierarchy graphs. This is what a hierarchy graph looks like using the notation of the book. Remember, I'm working from a book called Object-Oriented Design, and that book is dedicated to the topic of object-oriented design. Taking a step back, by the way, when you study software engineering, usually what happens is you get this super, super thick book with like 25 chapters in it, and then each chapter is dedicated to a specific topic, like, for example, the phases of the software development lifecycle, and then there is one chapter on object-oriented design. So like everything is compressed into this one chapter, maybe like 50 pages. And that's a pity. That's a pity. So what we're doing is we're taking a magnifying glass and we're zooming in on the object-oriented design chapter and we're expanding it. And that's what this book does, the book we're referencing. It goes into more detail about the object-oriented design process because it's ridiculously important. And it's the part of the software development cycle that people generally understand the least. So this is a hierarchy graph. And remember, hierarchy, in this case, this hierarchy graph is a class hierarchy. So we can use the is kind of logic, right? Selection tool is a kind of tool. Creation tool is a kind of tool. Ellipse is a kind of creation tool. Line is a kind of creation tool, and so on. And this notation here with a small rectangle or a box, a filled box in the top left of a rectangle. Each rectangle represents a class. And then this filled little rectangle in the top represents an abstract class. This is the notation used in the book that I'm referring to. which is slightly different than the notation used in UML. There is slight differences. I would say the notation here is a little bit simpler. UML often uses text, like a text label that just like literally says abstract class, for example. UML uses a lot of text, which is good, by the way. I think that's a good thing. But this convention of drawing an arrowhead from child to parent is common to both drawings, kinds of drawings. So multiple inheritance. This is what a multiple inheritance graph looks like. An array is a kind of ordered collection. An array is a kind of indexable collection. A matrix is a kind of array, a string is a kind of array, and a date is a kind of array. And string is a kind of, has a magnitude, and date also has a magnitude. And does anybody know why we don't use multiple inheritance generally? It's not a good idea to use multiple inheritance. That's an advanced question, by the way. If you know the answer to that question, that's really good. Like, if you know, that could be a job interview question for a developer job. Why would you want to avoid using multiple inheritance? So, Java does not support multiple inheritance. That was, yes, the cat has left the lecture room. King Kenny is his name. So one of the reasons, there are a number of reasons why we want to avoid multiple inheritance, even though it is supported in C++. One of the reasons is because, look at array, for example. Array is a child of ordered collection and indexable collection. Imagine you instantiate a new array, right? An array has a constructor. Okay, then a question is, array is a child of ordered collection and indexable collection. They both have constructors too, or they may both have constructors. Which constructor is executed first? So if I instantiate a new array and then there are two parents or three parents, of those parents, which constructor is executed first? The answer is you don't know, you can't be sure. And this is one of the major reasons that we avoid multiple inheritance. Multiple inheritance leads to behavior that is too difficult to understand and too difficult to predict, essentially. So we avoid it. That's only one of the reasons. It's not the only reasons. There's probably a Wikipedia page dedicated to this topic. Yep, there could be an issue if a base class calls methods with the same name. If both parents have a method with the same name and it's a shared name with the child class, this could cause problems, yes. Does anybody know how Java avoids multiple inheritance but also supports some of the characteristics of multiple inheritance, if that makes any sense? So what does Java support instead of multiple inheritance? Yes, interfaces, exactly. Interfaces can be thought of also as abstract parents. So purely abstract parents, and you don't need an explicit constructor, for example, or a constructor with an implementation, right? In an interface class, you don't have to have an implementation for any of the methods. So it's really an abstract class. Okay, great. I think that's enough for today. What do you guys think? We will pick up at this point on Friday. We have a lab on Thursday, a really fun lab. Thursday's lab has a little surprise in it that I hope everybody enjoys. And we will pick up on hierarchies and subsystems on Friday. Any questions before we close? Probably some of you are wondering where I got King Kenny from. King Kenny is from an animal shelter, so he was dropped off by his previous owners and, without any notice. And so I went to the animal shelter to adopt him. He's outside right now. I'll bring him back. And He'll be in the recording, so if you watch the recording of the lecture later on, you should see him on the chair back there. Okay, I will see everybody on Thursday then.